EDX Decision 1, Critical Path Analysis 1, Activity Network, finding critical activities and the critical paths. The minimum project completion time is the duration of the longest path through the network. In other words, the shortest time for all the activities to be completed. Any delay on this path will lengthen the whole project completion time, so this is called the critical path. The activities on this path are critical activities. To find the critical path, you need to work through the network twice. Forward, finding the earliest event times, and then backwards, finding the latest event times. Float is the spare time or capacity associated with an activity. It is important as it gives us information about the impact that delay on one activity will have on the entire project. Activities with zero float are said to be critical activities. Float becomes very important later on when we consider the scheduling of activities. The spare time on non-critical activities can be used to delay the start of some of the projects. This can enable one resource, such as a person or a machine, to carry out more than one activity without affecting the project completion time. Notice this specification only asks for the total float. So the total float of an activity, defined for example Fij, is the latest event time for j, take away the earliest event time for I, take away the duration. So for example, if we had this situation here, so we've got an activity E which lasts for 13, the earliest event time is 4, so the earliest it can start is 4, the latest it can start is 5, the latest event time, so the earliest it can finish is 17, the latest it can finish is 18. So the total float on E is the latest it can finish, which is 18, take away the earliest it can start, which would be 4, take away its duration, 13. So the total float for this activity is 1 unit of float. If we have a look at this network, so the earliest A can start is 0, the finish time is 6, so the earliest and latest finish are both 6, and it lasts for 6. So 6, take away 0, take away 6 is 0, so A has no float and is therefore critical. If we look at E here, the latest time that E can finish is 18, take away the earliest it can start 4, take away its duration 13, gives me 1 unit of float on E, therefore it's not critical. If we look at D, its start times are both 6, its finish times are both 16, and its duration is 10. 16 take away 10 is 6, therefore D is critical, and we see the same with F. Its start times are both 16, its finish times are both 20, and its duration is 4. 20 take away 4 is 16, so F is also critical. So critical activities have 0 float, and we've just seen that A is critical, D is critical, and F is critical. They must be completed on time. Any delay in A or D or F will delay the project, and therefore they are the critical activities, and ADF is the critical path. So here we're going to see the whole process from beginning to end now. We want to identify the critical paths in this network. In order to do that, we need to find out which activities are critical, and we can't do that until we do the forward pass and the backward pass. So running through the whole process now, you start with the first node, that starts at 0. The earliest event 2 can happen is at the end of A, so the earliest that can happen is 4. The earliest that event 3 can happen is at the end of C, and we need to finish B. So it's either 4 add 3 is 7 or 6. So the earliest that this can happen is 7. You go for the bigger time. If I put 6, I won't have enough time to finish C. The earliest that this event can happen, event 4, is the completion of E and the completion of F. So it's either 4 add 4 is 8 or 7 add 3 is 10. In order to finish E and F, I would need 10 units of time. The earliest that this event can happen is the completion of D, which is 11, or the completion of C and F, which along the dummy would be 10. In order to complete C, F, E and D, I would need 11 units of time. The earliest that event 6 can happen is either 10 add 2 or 7 add 5. They both give me 12, so the earliest this can happen is 12. The earliest event 7, it's either 11 add 3 is 14 or 12 along the dummy. In order to complete I and H and G, I would need 14 units of time. The earliest event 8 can happen is 14 add 5, which is 19. And the earliest I can complete this, be careful now, it's either 19 along the dummy, or 14 add 3 along L, or 12 add 9 along J. The earliest I can complete the entire project, therefore, would be the biggest time, 21. Now I'll work backwards. So if we complete this project in 21 units of time, what's the latest each event can occur? So just going through the events in reverse order, the latest event 8 can happen because of the dummy. The latest this event can happen would be straight along the dummy, 21. The latest that event 7 can happen, it's either 21 take away 5, which is 16, or 21 take away 3, which is 18. The latest that this event can happen in order to complete K and L would be the smaller option, 16. The latest event 6 can happen. It's either 16 straight down the dummy or 21 take away 9, which is 12. So we've either got 16 or 12. The latest it can happen to complete J and K and L would be 12. The latest that event 5 can happen is it can finish at I can finish at 16. Take away 3, the latest this event can happen is 13. The latest for event 4, it's either 13 straight along the dummy or 12 take away 2, which is 10. So it's either 13 or 10. In order to complete I and H successfully, we would need this to happen at 10. The latest that event 3 can happen, it's either 10 take away 3, which is 7, or 12 take away 5, which is 7, so that has to be 7. The latest event 2 can happen, it's either 13 take away 7, which is 6, or 10 take away 4, which is 6, or 7 take away 3, which is 4. The latest that this event can happen in order to complete D, E and C afterwards would be 4. And the latest we can start the project is either 4 take away 4 is nothing, or 7 take away 6 is 1. The latest we can start the project and complete A and B would therefore have to be 0. So now we're looking for critical activities. So A has to start at 0, it has to finish at 4, and it lasts for 4. That means A is critical. B starts at 0, finishes at 7, but only lasts for 6. So there's 7, take away 0, take away 6. There's 1 unit of float on this, and therefore it's not critical. C starts at 4, finishes at 7, and lasts for 3. So 7 take away 3 is 4, therefore C is critical. If we look at D, I can see there's float here. Yeah, so D could finish between 11 and 13, therefore D is definitely not critical because there's float at the end. E has to start at 4, has to finish at 10, but it only lasts for 4 units of time, so 10 take away 4, take away 4. E has 2 units of float, so not critical. F starts at 7, finishes at 10, lasts for 3 units. 10 take away 7, take away 3, 0. So F has no flexibility and is critical. G starts at 7, finishes at 12, lasts for 5. 12 take away 7, take away 5 is 0. G is critical. H starts at 10, finishes at 12, lasts for 2. So 12 take away 10, take away 2 is 0. H is critical. If you look at I, it's got flexibility when it starts, it's got flexibility when it ends, it's definitely not critical. J, be careful with J, starts at 12, finishes at 21, lasts for 9, so it is also critical. 21, take away 12, take away 9 is critical. K, I've got flexibility when it starts, I've got some flexibility when it ends, it cannot be critical. L has some flexibility as to when it starts, cannot be critical. So my critical activities are A, C, F, G, H, J, and there are 2 critical paths. There's A, C, F, H, J, and there's a critical path A, C, G, and J. And any delay in these critical activities will delay the completion of the project. As you can see, the critical activities clearly labelled on the diagram. So in summary, you prepare the network by listing activities and creating a precedence table. You draw the network with activities on the arc and events as the nodes. Use dummies where necessary. Analyse the network by calculating the earliest event time, which is called a forward pass, and the latest event times, which is often called a backward pass. Identify critical activities and therefore the critical path, and if required, calculate the total float on non-critical activities. You may then be able to assess the impact of any delays or changes to the activity durations on the overall project accordingly. And that brings us to the end of Critical Path Analysis 1.